Welcome to this presentation from YAML to root, CI/CD pipelines, attack, and countermeasures. My name is Hugo, or Spirit. I'm a senior pen tester in Deloitte, France, private teacher in C++ for more than 8 years now. Also, I do DevOps programming, pen tests. I'm also the one maintaining and deploying the pen testing and retrieving infrastructure that we use during our tests. More than 6 years in cybersecurity. Here, as you can see, there is another person, Luc Marie. He's not here today, but I would like to give him a special thanks because he helped me do the presentation. So thank you, Luc Marie. Before we start, let's give just a small context, a small presentation of what is pipelines and what is the DevOps, DevSecOps, etc. So DevOps, I think you all know what it is, and DevSecOps is the same thing with integrated cybersecurity inside all the steps. So first, in terms of DevOps, you know, it's everywhere. Every industries will have DevOps team in order to deploy software, infrastructures in their enterprise or in their networks, and it will rely on a set of tools combining codes and specific infrastructure. Here we will have the first difference between DevOps and the pipelines, where the DevOps will give you the culture for collaboration, so how you will work with your teammates, with all the developers, all the testers, etc. How do you manage your plan? And sometimes what you will need is something in order to deploy your code or do a specific action just by using one click, or if you are developing a new software, having the possibility by one click to deploy all your code to infrastructure or to a new artifact in order to share the new version of the software. So the idea is, that's why they created the CI/CD pipelines to make all the integration, testing, and deployment actions automatic. At the beginning, when those pipelines were created, they were only available for developers or administrators, but with time and currently, those are open to a lot more people. So for instance, there are a lot of companies that will give access to specific repositories to their commercial or marketing team in order to deploy easily a website. For instance, you just have to type the name of the website and it will automatically deploy it. You will also have, for instance, for HR, if they want to create a new user account, they will just have to put the name, the address mail, etc., and it will automatically do a lot of actions using those pipelines in order to deploy the new user into the industry. And so we begin with developers and administrators with a specific knowledge, some expertise on development, on cybersecurity, on those pipelines, on cloud. And then those pipelines are now open to a lot more people with different level of maturity on the subject. So it will open your network and your infrastructure, your cloud infrastructure, to a lot more people with different level of knowledge on the security. And that's why I decided to present this subject, where what we will see here is the scenarios, the most viewed scenarios as we saw during our audits on the CI/CD pipelines. And what we will look is on the pipelines used from the code to execution. For instance, the infrastructure as code, when you have Terraform. First, just to give you a little bit more information about the pipelines, here is a classical workflow for Azure DevOps. So Azure DevOps is by Microsoft. It's something a little bit like a GitHub. And what you have here is a classic workflow where you begin with the board in order to define the plan, the developers that will create the code, and then you put it in the repository, exactly like GitHub. And you will have the first type of pipeline, the CI pipeline, where you will have the code tested, published, and also if you want to deploy a new artifact, for instance, if you are developing softwares, the creation of artifacts. Then you have the CD pipeline, responsible for the deployment. So they will take the code or they will take the artifacts and they will deploy it inside your network, inside the infrastructure and all the environments. There are two kinds of pipelines in the CI/CD platforms. The first one are the platform hosted pipelines. So those one, like Microsoft hosted pipeline, GitHub Actions, are agents that are given by the platform. Usually you will have like 16 hours free or a few days free in order to use it, even if you are a company. And those one are not hosted inside your infrastructure, but you can use them as you want. You don't have to maintain it. You just have to use it and to deploy your code. But you have to open your infrastructure to an external source. The second one is self-hosted pipelines. Those one are directly hosted inside your network, inside your infrastructure. So you have to maintain it, to add all the new versions, to configure it. And the good thing here will be that they are already inside your network. So in terms of network accesses, you don't have to open your network to the outside, but it's a little bit more costly. And usually what we'll have is for cost optimization, the companies will use one runner, so one server with a pipeline inside for multiple environments and multiple projects. In this case, if someone is able to pawn, for instance, one project in dev environments, he will be able to access the production environment of another project or another subnets. And also, as we saw, that usually those pipelines, so the configuration and the security of those pipelines are managed by different teams than the one doing the projects. So in this case, the one doing the project doesn't have a view on the cybersecurity and the security maturity in order to use those ones. Now, before starting with the offensive parts, I will just give you some information. What you will see is, so there are real-world attack scenarios that we encountered during our audits. We will use Azure DevOps as a primary example, but all those attacks and attack scenarios are applicable to other platforms, so GitHub, Bitbucket, AWS if you use Code Catalyst, for instance. Only the last scenario will only be for Azure DevOps, but all of them works everywhere. Also, in terms of access, we will assume that we have a classic contributor access. So the idea is they give you the repository, and you are able to modify the repository and to launch a pipeline. But we'll see it a little bit in detail after. And in terms of scenario, what we will have is a focus on weaknesses in the YAML configuration file. So the YAML configuration file is the file that is used in order to describe the steps that the pipeline must go through. And also Terraform files. So I don't know if you know Terraform. It's a script language that will allow you to define an infrastructure like a VM, a subnet, etc., and it will deploy it. And for each of those scenarios, we'll have different contexts, different prerequisites, and also different security restrictions that will be put in place. Lastly, the last terminology for those that are not used to Terraform, we'll need it a little bit after. Some keywords. The first one, providers. Providers are like packages in Python, and that some libraries that you will use in order to connect to specific infrastructure, external sources. For instance, if you want to create a VM on Azure, you will need Azure RM provider. There is one for AWS, for F5 BigIP, for instance. The second one, resources. Resources are the assets that you want to create. So a VM, a virtual network, a subnet, a network security rule, etc. Data sources are a function that will allow you to retrieve data about existing resources. For instance, you know the name of a subnet and you want to know the IP ranges. So you can use a data source, give the name, and it will retrieve the IP ranges. Provisioners are actions that you will use on existing resource or when you create a resource. So you will create a VM and you want, when the VM will be deployed, you want a specific code to run inside this VM. You will use provisioners. And finally, modules. Modules are just a package in Python. If you want to, let's say you have a piece of code that you like, you want to reuse it, you will create a module. And like this, you can recall it every time. Now, the scenario. For each scenario, what you will have is using which file, so YAML configuration in this case, and also what kind of attack scenario we will use, and also you will have here what you need. So all the user rights that you see here are, even the one in red, are the ones that you have by default if you have a contributor access on Azure DevOps or on GitHub. But just for all the scenarios, I will put in green only the ones that you need for this attack. So here, in order to perform a RCE with YAML configuration file using the script tags, you will need root access to the repository, root access to the YAML file, the possibility to modify the build configuration, we'll see it a little bit after, and the ability to trigger a pipeline automatically or by clicking on the pipeline. So, what we have here is, let's imagine we have a classic project with a YAML file and Terraform file that will deploy a VM. The classic schema that you can find. We go on the pipeline, we launch it, and we can see it deploys a VM. Perfect. Now, let's say there is no security on this pipeline. You can do what you want. You just have to add, here you will have a wget in order to obtain Nabu. Nabu is exactly like Nmap. And you have also a code that will deploy a reverse shell. So you use a remote server. Just wait a little bit. Let's move on a little bit. Sorry. And now, just launch, and now you have access to the pipeline, and you have a reverse shell on the pipeline, just by using like 4 lines of code. This one, you may think that it's quite easy. We saw it a lot in companies, but this one is a less secure example where you have access to the YAML file and there is no restrictions. But it happens. Also, something important here, we use the wget in order to access something on internet, and we use bash in order to access also to use a reverse shell because we are using Microsoft hosted pipeline here. So we have access to internet. This is by default on the Microsoft hosted pipelines. If you don't have access to internet, you can still do echo or cat of etc shadow. You can do all the actions, so run code without using internet. It works also. But if you have outbound access, you can do your reverse shell. Second case here is, let's say we had a new security, so we will add a blacklist of all dangerous tags. There are lots, there are scripts, there is another one called bash, and another one called command, a lot of them. What we can do, we can still work with this, what we can do is we will use official task. So here you will have Azure CLI. Azure CLI, it's an official task, like a function that is provided by Microsoft. There are a lot of them, like one for GitHub, for AWS also. And this task will use the service connection. So the service connection in Azure is when you are on the Azure cloud and you want to create a service principal, so a service account for your pipeline, you will take the service account and you will put it inside a service connection. And this service connection will hold the credentials of the service account for the pipeline. So the pipeline will use the service connection in order to connect. So you just need the name of the service connection. This is not a secret. This is just the name of the service. And once you have it, you can deploy directly your code inside. This is a built-in task. So here what we have is an echo. Here what we have is, because we are using the service connection, we have access to the cloud infrastructure behind. So using this task, you have the same rights as the pipeline. So here we will create a new service principal on Azure, and here we will display it. So using official task, you are able to deploy code on the pipeline, but using this one, you are also able to directly access Azure behind. Now, let's change and let's say, okay, now we don't have access to YAML anymore. We only have access to Terraform. On this one, there are a lot of things to do also. So here you can say don't have access to YAML. What we will do this time is we will use what we saw, so the providers and also the provisioners. So providers, we go on provider.tf and we add external, which is an official provider. We can then go to the main.tf file where you define all your infrastructure. And here, what we'll have is, sorry, it's a little bit blurry, but you will have a data source called external, which is provided by the provider external. And this data source allows you to run code directly on the pipeline. So we will use it. And also below what we have is local exec, which is a provisioner. And we use, I don't know if you can see, but we use a resource called a null resource. This one is an empty resource just in order to use a provisioner in it, but it will do nothing on the infrastructure. And on this one, you just have, oh, sorry. We just had those two lines. Why don't I have the video on this one? Okay, perfect. So, yeah, with only those, we can run it. And then at the end, you can see we're able to execute the code on the local provisioner, so local exec, and also we're able to execute the code on the pipeline using external. Now, let's add a new security again. Let's say we blacklist all dangerous providers. So there is external, there is another one called local. Local will allow you to use a function called local file. Local file allows you to create files and read files inside your pipeline. So let's say it's blacklisted. And also we'll blacklist all provisioners. So there are two local execs that we saw earlier, and another one remote exec, and remote exec will ask for credentials. So usually we will use local exec. But let's say we will blacklist all of them. So now what we can do is create our custom provider. It's quite easy. The idea is you go inside the Terraform registry, the HashiCorp Terraform registry, which is official. You go inside, you just create an account, and there is a very good documentation saying, okay, if you want to create your custom provider and make it official, you can. So that's what I did. What I did is I made a fork of the external provider because it's on GitHub. And I modified it a little bit by saying, okay, no, your name will be tests. And also I want you to execute some codes if I put the keyword command. And then you just have to deploy it. Again, you just have to read the documentation inside HashiCorp registry. It's pretty complete, pretty easy. So what I did at the end is add a new provider called test from Spirit 91 test and use it as a data source test, command who am I and ID, and it works also. So like this, you're able to execute the pipeline even if the providers are blacklisted, because most of those restrictions are based on the string of the name of the function. So if external is blacklist, you can use another keywords as you want. I put test, but you can use every keyword and it will work. Just for your information, this provider, so Spirit 91 test, is still existing. So if you want to use it, do not hesitate. You just have to add it like this and to run the command like this. Finally, last scenario, let's say that you don't have root access to the repository. you don't have root access to the YAML file, to the Terraform file, you have the possibility to modify the build configuration, which is by default on a contributor access. And you have the possibility to create a service connection, again, by default on the contributor access, because the contributor account on Azure DevOps and on GitHub is member of endpoint creators by default, and endpoint creators have the right to create service connections. And finally, the ability to trigger a pipeline. So what we will do here is we can see that we don't have access to any files, which just can launch a pipeline. We go inside the pipeline, we try to edit it, and they will say you don't have access to the YAML file, so you cannot modify it. However, in Azure DevOps, there is something called the classic editor, which is enabled by default and cannot be disabled. So what we will do is go inside the classic editor, say, okay, I don't want you to take the code from Azure DevOps this time. I want you to change and to take it from GitHub. So we switch, we go on GitHub, you create a public repo just with a main file, a few lines of code to do the reverse shell. You create your token. This is a view once token, remember it for the next parts. And you put the token, you just refresh the page. Because you can create a service connection, it will automatically create one using GitHub. So you save. And then you just have to launch the pipeline again. Here is our remote server. And now you have access to the pipeline without modifying any files inside the repository, just by using the configurations and the possibility that by default you can create a service connection. So pwd to see where you are, ls to see who you are, id to see who you are. So this one will work. So here we saw a lot of attack scenarios that you can use in Ansible or in Terraform, in the YAML file or in Terraform. There are also a lot of other ways, a lot of other attacks, also using Ansible. But so we have the possibility to do a remote code execution. What can we do next? So first, what we can do is try to exfiltrate some secrets. So you have access to the pipeline. You will look at the pipeline to see if there are some secrets in the environment variables or in some files, and you will try to send it by using a curl to your remote server or to echo it. Issue on all the platforms, when you try to echo or to cut a password or a secret, it will mask it with stars. So the idea here is that base 64 of a secret for the CI/CD platform is not a secret. So one tip, if you encode a secret on base 64, you can display it. It will not be masked. So you can display it, you can send it, you can display it directly on the console and copy it and then decode it. Second one, you can use the privileges of the pipeline in order to access other repositories. As we said, sometimes those pipelines are shared between multiple environments or multiple projects. Or you can try to expand it and go inside the cloud resources, as we saw with the Azure CLI task that will allow you to go directly on Azure. And finally, you can also try some lateral movement. So as we saw, we tried to wget Nabu, which is the same thing as Nmap. You can use it in order to do some network scan using the pipeline, or try to access other projects or other clients like a competitor that are reachable from the same runners. In terms of exfiltration of secrets, I told you, try to remember the GitHub token, which is a view once token. The view once token are the secrets that we'll create. It will be displayed only once, and you can copy it. And then once you copy it, even the administrators cannot retrieve it after. So you have GitHub when you try to generate a token that will be only deployed once. You will have also, if you create a service principal on Azure, they will display the password only one time. You copy it and then you cannot retrieve it. But we found a way in order to access it. So it's not really a view one secret. We'll saw it a little bit after. Something that we saw also that because those secrets are normally accessible only once, available only once, teams and security teams used to put too much trust into them and into the integrated functionalities of the CI/CD platform. So, as I mentioned, the service connection in Azure DevOps, you will put the credentials of the service principal, and then you just have to use the name of this service connection. So we'll say, okay, it's secure because it's directly inside the backbone of Azure. I don't have to use it. Perfect. Unfortunately, it's not really. So because a lot of people think they are really secure, they will tend to give a little bit too much permissions on those pipelines. And then if someone is able to access those secrets, they can reuse it and directly access the infrastructure behind. So that's what I did here is, I saw that for this task, it was using AZ login. And by doing some research, I thought that AZ login was a node, it was coded in Node. So it's, you can find the documentation on GitHub. And what I did is, okay, so it's coded in Node, perfect. But all those secrets are injected inside the pipeline because it's only viewed once. You can store it, but all those Azure DevOps or GitHub retrieve those secrets after, or they're able to inject it inside the task. Because in the Azure CLI, we only put the name of the subscription. So all are able from the name to retrieve the secrets. So what I did is a wrapper of AZ login saying, okay, if you type AZ, you will go inside my AZ. You will display everything that you have every time you use login. So you will display all the flags. You will send it to me and put it as base 64. And then you will run the original AZ login. So that's what I did. Let's do a little bit quicker on this one. So I run the pipeline with the task as a login also, as a CLI also. And here we can see I'm able to retrieve here. So minus U, this is a username, minus password. I have the password here of the service account, which is normally viewed only once and which is not accessible even for administrators. Like this, I can retrieve it and reuse it after. It works also for federated identities. So if you want to create specific token and not use password, it will work. So what I did after is put it in base 64 in order to retrieve it. What I did after is, okay, so we have access to Azure login. It works. So I think it will work on AWS login if you use this task. But are we able to retrieve all the credentials every time? The answer is yes. What I saw is every time you're using a task, so on Azure DevOps, on GitHub, on AWS Code Catalyst, it will also it will inject the environment variables inside this task in order to initiate the task, and then it will clean it before giving access to the user in order to use this task. So the idea here is we try to find which version of Node is used and what is this path, the path of the node. What I saw is that for all the platforms, they are not using a built-in version in /user/bin. What they are using is a cache version that they will download and put in the same folder as the task when we ask for a task. So what I did is try to find this this node version and override it. So I overrided the node version to do exactly the same thing. Okay, display me the environment variables and send it to me. Oops, sorry. Okay. So you just have to launch it. And then you have your small code that will decode the base64. And what you have here is all the environment variable decoded. And here, the service principal key, which is unvariable sent. And here also. And this one will work for Azure DevOps, for GitHub, for AWS, etc. You work for all of them. In terms of network, we tried also to see what can we reach using Microsoft hosted pipeline. Is there some limitations, some restrictions? So Microsoft is publishing every week a JSON file with all the public IPs that they are using. So inside, every time you are in Azure and you will ask for a public IP, your public IP will also be inside the IP ranges on this file. So those are all the public IPs that Azure have and can provide to the users. Also, here you have the public IPs of all the Azure assets from the backend infrastructure. What we did is run SSH and WinRM, so two protocols that are used on Ansible, on all those IPs that are allocated to public. And we did it using Nabu on AWS VM. So you have the results here. On Azure VM with also an IP assigned by Azure, and on Microsoft hosted pipeline. What we saw from these results is that we have almost 300,000 IPs that are open to the network and accessible from an Azure VM or Microsoft hosted pipelines. And inside the whole, I think there are 47 million IPs. So between them, there are 300,000 SSH open. And we see that for AWS, only 68,000. The idea is, by this research, we think that the reason is, by default, you will have some trust relationship between so let's say the clients that are using these IP addresses and their infrastructure, and they will open it to everything in Azure, because one issue is every time you are using Microsoft hosted pipeline, you don't know exactly which IP they will use. And from the documentation, they will say, okay, we are using either one specific IP from a range called Azure DevOps, or one IP from the region of the Azure DevOps. So you don't have any way to know from where your Microsoft hosted pipelines will take its IP. So usually companies, what they will do is they will open their network to everything in Azure, saying, okay, by default, it's secure. But if you use an IP, if you ask an IP to Azure on a VM, or if you use Microsoft hosted pipeline, which are free, again, you can access it and you can SSH it or WinRM it. And we can see also that between those 47 million IPs, 70,000 are open to the full network, because here we are on AWS. So either they are open to full network, or either they are allowing only AWS. We don't know, but yeah. I tried also with GCP, but after 1 hour, I was banned, saying, oh, you are trying to scan third parties, and it's not allowed. They told me I can call them in order to have access to my organization back, but I say no. Quickly also, sorry for the time. Here, I said that I scan using Azure VMs and Microsoft hosted pipelines. The thing is, by default, Microsoft hosted pipeline doesn't authorize scans. You will be blocked. So here we have two projects. One that will deploy Nabu and launch it like this on the pipeline. And also one that will do a reverse shell and deploy Nabu in the same thing and launch it. And the last one we'll see. So first, we tried Nabu on the pipeline, we have a timeout because you don't have the access. There are restrictions on the user shell. Next, we'll do the same thing, but this time we'll create the reverse shell. We launch a pipeline. We launch Nabu again. We wait a little bit. Timeout again, because you are still in the user shell. The idea is, here what you will do is, because the console in Azure DevOps GitHub are not interactive, you cannot do a sudo-su. So you put the PTY in order to do an interactive console. You launch it. And now you're able to do sudo-su to become root and to access the root shell. And from this, you bypass all the network restriction from Microsoft and from the Microsoft hosted pipeline, and you can launch your Nabu so you can scan anything and it will work. Finally, in terms of the defensive part, as you can see, there are a lot of things you can do in order to block this. So from the access is a secret, isolation of the network, hardening, etc. The thing is, it's impossible to put all of them because it will really depend on how you use your pipelines and how you use your infrastructures. So the idea is every time you will deploy a pipeline, you will need to, let's say, audit it, do an audit and find which security you can put without affecting the accesses, without affecting all the actions that you want to do. Usually what you will try is avoid root accesses, of course. And one good thing is to use short-lived pipelines. So pipelines that would run on Docker like this, even if someone is able to access it, it will be destroyed after a few times. And also in terms of audits, if an auditor come to you and say, okay, I will audit your pipeline, and they have checklists, not a good auditor, because again, you cannot put all of them inside your pipeline. You can, but it will be very restricted, and in terms of user experience, in terms of administration, maintenance, it will be hell. So usually, even for the audits and for the hardening, there is no universal solution. It's more based on how you will work, but those are all the things you can do. Finally, the key takeaways. Currently, during our tests on the CI/CD pipelines, we have 100% success rate, and usually we are able to achieve it in 1 to 5 days. It's not to say we are the best at all. It's just to say that currently they are not mature. So it's pretty easy, as you saw the one where I just put a few lines of code, the first scenario. I saw it a lot of time. So in terms of CI/CD, usually companies are not mature at all. Second, most of the agents run as administrator or root. Here we saw example with Linux pipelines, but it works also with Microsoft. And most of them run as root. So once you are able to launch code, and it's easy, you have access to the pipeline and you can do what you want. Good thing is the rise of Docker. So now more and more we can see that they are using Docker every time they are launching a pipeline. So even if you have access to you are able to launch code, you will be restricted to a specific container. So at least that's a good thing. In terms of segmentation, also, it's often poorly implemented. For instance, I was able during audits to find that I had access to a pipeline, and from the pipeline, I run Nabu on the same network of the pipeline, and I was able to access a domain controller using this, because the pipeline was in the same subnet as the domain controller of all the company, the two domain controllers of the company. So put them in a specific network segmentation like this. If someone is able to access it, they cannot lateralize to something else. And finally, the lack of effective monitoring. Usually when you are able to execute code on the pipeline, you are able to do what you want because there is no monitoring or a very few monitoring actions, so all your attack will go undetected. For instance, the best that I saw in a company on this was on HashiCorp. So in order to, a little bit like Azure DevOps. And on HashiCorp, the security was, you will have a pop-up saying, okay, on your code, you are trying to run, it was external with the command, who am I? It's dangerous. Do you want to execute it? Yes. And it worked. So it was, the only security was just a pop-up saying, it's dangerous. Do you want to do it? Yes. Okay. And there was no log after, just a warning. And here are all the references that I use for this presentation. And thank you very much. And if you have any questions.